Geometry 4-5. Proving triangles congruent. Using angle, side, angle, and angle, angle, side. Postulate 4.3 in our book. Remember, ignore the numbers. Angle, side, angle. Or angle, side, angle, congruence. Let's draw two triangles. ABC and triangle DEF. If I have a triangle where two angles are congruent to, if I have a triangle where the corresponding angles, two pairs of corresponding angles are congruent, and the included side is congruent, then I know that my triangles are also congruent. So, if two angles and the included side are congruent, then the triangles are congruent. All right, let's do an example of what that might look like. So I'm going to have this kind of arrowhead looking shape. And this is P, Q, R, S right there in the middle. And I'm given that QS bisects angle PQR, and angle PSQ is congruent to angle RSQ. All right, prove that triangle PQS is congruent to triangle RQS. All right, let's label QS bisects PQR, PQR. So QS bisects this. That means that PQS and SQP are congruent triangles. But we need to prove that. That's just what this means here. We need to say that in our proof. PSQ is congruent to RSQ. Oops, this should be an R down here. So RSQ and PSQ, these two angles are congruent. All right, so let's set up our proof, and then let's make a strategy. Okay, so I'm going to put all of this stuff down here as the given, and I'm going to write given here. Now I'm going to make a strategy. So I want to prove that PQS, triangle P, that this triangle up on the top is congruent to this triangle here on the bottom. I know that from the given that these two angles are congruent. I'm going to be able to say that these two angles are congruent because this segment bisects this angle, cutting it in half so that these two angles are congruent. But I got to say that in my proof. And then I have angle, angle here. So I need a side to prove that these two triangles are congruent. And I'm going to say that SQ is congruent to SQ by the reflexive property because every line segment is congruent to itself. And then I'll have angle, side, angle, and I can prove that these two triangles are congruent. So first, I'm going to prove that these two angles are congruent. I'm going to say that angle PQS is congruent to angle RQS, and that is the definition of an angle bisector. Okay, got that one out of the way. Now I'm going to prove that SQ is congruent to SQ. So these two segments are congruent, and that is by the reflexive property. And then, now that I have side, angle, side, side, angle, side, I can say that these two triangles are congruent. Triangle PQS is congruent to triangle RQS by angle, side, angle. All right, let's look at another theorem. Instead of a postulate, it's a theorem this time. Theorem 4.5, I don't care about the number. Angle, 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 side. Angle, angle, side. Congruence. All right, so angle, angle, side, I'm going to draw two triangles. That should look like they're the same. Got a little bit messy there. All right. So I've got these two triangles, and they are triangle RSQ and triangle LNM. And these are supposed to be congruent, though I didn't draw them very well that way. R and L are congruent. M and Q, these angles, are congruent. And then QS, segment QS, is congruent to segment MN. So I've got angle, angle, side. Okay. So if two angles and one non-included side are congruent, then the triangles are congruent. Let's do a proof. Well, we'll do a proof in a second. We're going to do a summary of the triangle congruences here. And so we're just going to do a little chart. If I've got two triangles, like this, then the sides, corresponding sides, are congruent to one another. Then I've got side, side, side. If I've got two triangles, and I've got one side and then an angle and then another side, one side and then an angle and then another side, then I've got side, angle, side. I've got two sides and an included angle. Side, angle, side. Two more triangles here. And if I've got angle, side, angle, angle, side, angle, then I have angle, side, angle. And then one more. Oops. Side, angle, angle, side, angle, angle, or angle, angle, side. two sides, and a not included angle. So these are our four main postulates or theorems that we're using to prove triangles are congruent. Let's do an example. I've got my given. Angle K is congruent to angle M. KP is perpendicular to PR. MR is perpendicular to PR. Prove that angle KPL is congruent to angle MRL. All right, so we're proving angles again. Up on the right, left is K, down below K is P, to the right is R, up above R is M, and in the middle there is L. All right, we know that angle K and angle M are congruent. Angle K and angle M are congruent. KP and PR, KP and PR are 90 degrees perpendicular. MR and PR are also 90 degrees. Okay, so we want to prove that KPL, we want to prove that this angle here is congruent to this one, MRL. All right, let's set up our proof. And then let's make a plan. Okay, so I've got these two angles that are congruent. And I want to prove that this angle is congruent to this angle. Now I can prove that these two angles are congruent because of the vertical angles, because vertical angles are congruent. So I know that. And so now I can have two angles here that are congruent, but I don't have any sides, and I don't have any angles, any other angles. But I do know that if I have two angles that are congruent in a triangle, then the third angle is also has to be congruent. So remember back from a couple lessons ago that if I have two angles that are congruent in corresponding angles, then the third angle also has to be congruent. So that's what we're going to use to prove that KPL is congruent to MRL. So we take our given, put that right here, and that's because it's a given. And then we just say that KLP, angle KLP, is congruent to angle MLR. And that is because vertical angles are congruent. I'm just going to write vertical angles and put a little congruent sign. Now I can just say that angle KPL is congruent to angle MRL by the third angle theorem. And that's as easy as it gets, I guess, if you remember the third angle theorem. And that is 4-5. There might be a 4-5A to talk about some right triangle congruence. We'll see about that. But otherwise, have a good time doing your homework.